Hello friends, today we are discussing the relativistic mass energy equivalence, that is mass energy equivalence, or we are going to prove the universal uh, formula. That universal formula is Einstein's mass energy relation, that is E is equal to mc square. As we know, the rate of change of momentum is called the force, that is F is equal to dp by dt. And as we know, the P is equal to m into v, so we are substituting the value d into mv by dt is equal to f. According to the theory of relativity, both the mass and velocity are variable. Therefore, we can write f is equal to m dv by dt plus v dm by dt. Let the force F displace the body through a distance x. Then the increasing kinetic energy dEk of the body, that is equal to the work done F dx. Hence dEk is equal to F dx. Substitute the value of F, so we get m dv by dt plus v dm by dt into dx. By rearranging, we get m dv by dt into dx plus v dm by dt into dx. So kinetic energy, change in kinetic energy is equal to dv by dt is nothing but change in velocity, that is mv, v there is, so mv dv plus v square dm then as we know the rest mass or the relativistic mass, that is m is equal to m0 by under root of 1 minus v square by c, already we discussed in relativistic mass. So squaring on both sides, we get m square is equal to m0 by m0 square divided by root of 1 minus v square by c square. So by rearranging, we get m square is equal to m0 c square by c square minus v square. So m square c square is minus, or we can say just m square c square is equal to m0 square c square plus m square v square. Then differentiating this term, we get c square twice of m dm is equal to 0 plus m square 2v dv plus v square 2m dm. Since m0 and c both are constant, so c square dm is equal to mv dv plus v square dm. So from equation 3 and 5, we get the kinetic energy, change in kinetic energy is equal to c square dm. So equation are same, the right hand side of the equations are same. So the change in kinetic energy is directly proportional to the change in mass dm. When a body is at rest, the velocity is 0, and as the velocity is 0, the kinetic energy is 0. So mass is also, mass m is equal to m0. m0 is the rest mass. When its velocity is v, its mass becomes m. Therefore, integrate the equation 6. So after taking the integration, integration limits m0 to m c square dm. So ek is equal to c square m minus m0, or ek is equal to c square by c square into m minus m0. This is the formula for the relativistic kinetic energy. When the body is at rest, the internal energy stored in the body is m0 c square dot m0 c square. So m0 square c square is called the rest mass energy. The total energy E of the body is the sum of kinetic energy and rest mass energy m0 c square. So just substitute the value, that is total energy E is equal to Ek plus m0 c square. So we get Ek is equal to mc square minus m0 c square. So by substituting the Ek value, E is equal to mc square minus m0 c square plus m0 c square. So we get E is equal to mc square. This is the Einstein's mass energy relation. This relation states a universal equivalence between mass and energy. It means that mass appears as the internal energy and energy as mass. Later on, the formula for kinetic energy reduces to the classical formula if V is far less than C. So we get the kinetic energy that is half m0 v square. So this is classical kinetic energy, and this is the relativistic equivalence of mass and between mass and energy. So this universal equation is referred as the relativistic mass energy equivalence. So this is the last topic of the fourth unit. I hope you understand all these chapters, topics. Be prepared for the pre-semester examination. So thank you very much.